Hi, hello everyone. Welcome back to DataSurface. If you are new here, I recommend checking out the playlist and watching the previous videos in this series to build a strong foundation for this video. So let's get started with today's topic. As part of our data fundamental series, today we'll explore about OLTP systems. So what is meant by OLTP systems? So basically, the OLTP stands for online transaction processing, which is a type of data processing system that involves executing multiple transactions simultaneously. Which means it is a one of category of data storage and processing systems where multiple transactions involved simultaneously. Dynamically, we can execute the multiple transactions. Right? So these OLTP systems support day-to-day operations by processing real-time transactions. Right? And OLTP systems are designed to handle high volume of short online transactions effectively, which means these transactions are typically like small, quick, and involves inserting, update, and deleting records. So now coming to the OLTP system types or categories, like OLTP systems comes in various forms based on their architecture, scalability, and purpose, such as like a distributed, centralized, cloud-based, hybrid, and real-time OLTP systems. However, we won't deep dive into these types here as they're not the primary focus for today's discussion. Okay, since most of the databases falls under the OLTP category. So whenever we are talking about OLTP under the hood, all the databases will comes under this OLTP systems category. So let's focus on the types of databases used in the OLTP systems. So the databases for OLTP systems can be broadly categorized into two types. One is SQL or relational databases. Other one is NoSQL or non-relational databases, or I would say SQL OLTP systems or NoSQL OLTP systems, right? So relational database management systems are all SQL databases. Like if you see in the diagram, like MySQL, PostgreSQL, Oracle SQL, or SQL Server, all this comes under as a SQL databases are relational database management systems. Basically, these databases will deals with the structured data. So in order to manage these databases, we will use the structured query language, means SQL language. And data is organized into these databases in the form of tables, which is a combination of rows and columns, and relationships are defined through the foreign keys. Okay. Now coming to the key characteristics of this particular SQL databases. The primary one is ACID compliance ensures the transactions reliability and data integrity. What it means, like what is the ACID properties? Basically, there are four types of properties will compliance by these all SQL databases. Atomicity ensures all operations in the transactional complete or none do. So like if you are doing some set of transactions, ideally, so it will make sure either it should complete all the transactions or it should make like roll back everything, right? So that flexibility will be there, and consistency keeps the database in valid state, and isolation ensures the transactions don't interfere with each other. As I mentioned, if you are executing set of transactions, all the transactions will execute independently. And durability guarantees the data persistence. Means once the transaction is successful, the data will be stored permanently. So these are the ACID properties which is compliant by the SQL databases. And other characteristics is structured data, well-defined schema and rich data structures. So this means if you want to store the data in SQL databases, you need to define the schemas so that it will be easy for us to access the data. Okay. So these two main characteristics are complaints by the SQL databases. Of course, there are multiple characteristics are there. I have considered here only key characteristics. Okay. So examples, as I mentioned, like Oracle database, MySQL, Microsoft SQL Server, PostgreSQL, all these databases will comes under the RDBMS or SQL databases category in OLTP systems, and which will maintain the structured data. And we'll use the SQL language to query the data or analyze the data or modify the data. Okay, we will dive deep into the SQL language in upcoming sessions. Okay, so now coming to the second category, NoSQL or no relational databases. So these systems will provide the flexible schema and designed to handle the mostly semi-structured data. So structured data will be handled by the SQL databases. Semi-structured will be mostly handled by the NoSQL databases. Like if you see the characteristics of this particular NoSQL databases, scalability, schema flexibility. So the scalability is basically if you want to scale up for high volume transactions, can easily scale up here because we don't have a predefined schemas in the NoSQL databases. So dynamically you can store the data. The data will be mostly stored in the form of key pair values, column family, or graph, or document. The MongoDB is basically store the data in the form of documents, and Cassandra is basically store in the form of column family store, and Redis is basically store the data key value stores. Right, so it is a kind of a JSON format. The data will be stored in the form of these NoSQL databases. Right, so these are the pretty much two categories which are available in the OLTP systems in a broader way. So now coming to the OLTP systems use cases. So OLTP systems for many day-to-day applications like banking, retail, travel, healthcare, telecommunications. If you look at the banking, fund transfer, account management, and retail, inventory tracking, online purchase, travel, airline ticketing, hotel reservations, healthcare, patient records, appointment scheduling. So whatever these entries are made in through the systems, all those data will be stored in these OLTP systems only. That's where we have mentioned, right? OLTP systems is mainly designated to deal with the day-to-day transactions.
That's all for today. Thank you for watching. If you like this video, please give it a thumbs up and let us know your thoughts in the comment section. Also, don't forget to hit the subscribe button for more data engineering tutorials. I'll see you in the next video. Until then, take care. Bye bye.